Hello everyone. Today we are going to discuss about organometallic compounds. Now, in organometallic compounds, what kind of molecules are placed? Let's see this first. The most important organometallic compound that we will going to discuss, that is Grignard reagent. It's basically alkyl or aryl magnesium halide. Another one, organolithium compound. Next one, dialkyl or diaryl cupric lithium. Next one, organozinc. Organocadmium, etc. The most important one for us, that is Grignard, and little bit important, organolithium and dialkyl cupric lithium. Now let's see what does it mean by organometallic compounds. Organometallic means when a metal atom will be directly attached with the carbon atom. Those molecules only will be known as organometallic compounds. Suppose CH3 MgBr. Suppose CHLi. Suppose CH3 CH2 whole 2 CuLi. So see, in this kind of compounds, the first one, methyl group is directly attached with the magnesium. In the next one, phenyl group is directly attached to the lithium. In the third one, ethyl group directly attached with the copper. So this kind of molecules will be known as organometallic compounds. And which will be not organometallic compounds? As for example, CH3ONa, CH3CH2, SNa, those kind of molecules. Why they are not organometallic? Because in those molecules, the carbon atom is directly not attached with the metal atom. So they are not at all known, will be known as organometallic compounds. Here we are going to discuss in detail Grignard reagent. Okay. Now what is Grignard reagent? if any alkyl or aryl group is directly attached with the magnesium and magnesium is attached with halide, they will be known as Grignard reagent. That means basically organomagnesium compounds will be known as Grignard reagent. Now, how can it be prepared? At the very beginning, Victor Grignard in 1912 first synthesized methyl magnesium iodide, and that's why, according to his name, this reagent has been known as Grignard reagent. And this reagent is so much important in organic synthesis point of view. He got Nobel Prize later on. So let's see the preparation of the Grignard reagent. I'm starting with methyl bromide. Methyl bromide on reaction with magnesium in dry ether produces Grignard reagent. Now, one important observation is here that initially when we have taken methyl bromide, in that case the methyl is electrophilic in nature, but after formation of the methyl magnesium bromide, methyl is nucleophilic in nature. That means in this reaction the polarity of the methyl group has been changed or reversed. That is known as ampola. That is reversal of polarity. So see, in the methyl group at the beginning it is positively polarized, that is electrophilic. Next it becomes negatively polarized, that is nucleophilic. So by this way, from different molecules we can prepare the corresponding Grignard reagents. As for example, suppose you have taken chlorobenzene, suppose you have taken ethyl iodide, okay. So by this way we can prepare Grignard reagent. Now, how Grignard reagents will react? Since Grignard reagents, the alkyl or aryl group is nucleophilic in nature, so in two ways the reaction can be happen. In two ways. Number one, acting as base. Grignard reagent on reaction with any molecule having active hydrogen will abstract those active hydrogens to form corresponding hydrocarbon. Now, what is active hydrogen? Active hydrogen means the hydrogen is directly attached with strongly electronegative element. As for example, if hydrogen is attached with oxygen, if hydrogen is attached with fluorine, if hydrogen is attached with C triple bond C, this kind of carbon, so those hydrogens will be abstracted by the Grignard reagent. So let's see one reaction here. Suppose we have taken CH3 MgBr. It on reaction with water, we will get methane molecule along with MgBrOH. How the reaction occurred? Let's see. Okay. So in this similar way, if it is treated with ethyl alcohol, we will get benzene along with if it is treated with this kind of enol molecule, so by this way we can see the action of the Grignard reagent as base. And another part is acting as nucleophile. How it will behave as nucleophile? Let's see. Suppose we have taken CH3 MgBr and one electrophilic center has been taken. Suppose this one. Any carbonyl. So this carbon is electrophilic in nature because it is directly attached with the strongly electronegative oxygen atom. So right now, the negatively charged, negatively polarized alkyl group will attack this electrophilic carbon, and this double bond will be removed. So what we will get this kind of adduct, and this reaction will be speeded up depending upon the nature of the electrophile. As for example, if we have taken aldehyde, the rate of reaction is very fast. Then it will be for ketone. Then it will be for acid halide. Then it will be for acid anhydride or then ester, and ultimately for the electrophilic alkyl group. Okay. So this order will be followed by the Grignard reagent for the nucleophilic addition or nucleophilic substitution. Now, in laboratory, how do we use the Grignard reagent? The addition process of the Grignard reagent is we have to take the Grignard reagent dissolved in dry ether. Now, the question, why dry ether? If little bit water or alcohol present in the ether molecule, then the Grignard reagent will be reacted with those water or alcohol molecules, and we will get the corresponding hydrocarbon. Those reactions already you have seen. So we have to take dry ether, and at low temperature, we have to maintain the low temperature, and then we have to add drop-wise the substrate to the Grignard reagent. That is the normal addition process. Okay. So let's see some preparation of some functional groups by using Grignard reagent. Okay. Number one, hydrocarbon. Hydrocarbons can be easily prepared by the Grignard reagent. How? Already you have seen. Grignard reagent plus active hydrogen containing molecules. We will get hydrocarbon. Next, number two, alcohol. For alcohol, if we use formaldehyde, we will get primary alcohol always. If we use any other aldehyde other than formaldehyde, we will get secondary alcohol always. And if we use ketone, then we will get 3-degree alcohol or tertiary alcohol. See? At first, it will be produced. Then on acidic hydrolysis, we will get this is 1 degree. If we use any other aldehyde other than formaldehyde, suppose we have taken acetaldehyde, in that case, what we will get? To degree alcohol. And if we will take ketone, suppose we have taken acetone, then we will get three-degree alcohol. There are obviously some other processes to form alcohol by Grignard reagent that has been discussed in the classes and in notes elaborately. So please go through that. Next, we are moving to carbonyl compounds. Next, see how carbonyl compounds can be prepared. Carbonyl compounds, basically, if we are talking about aldehyde, it can be prepared by using ester of formic acid. Suppose we have taken ethyl formate. It on reaction with any Grignard reagent, suppose methyl magnesium bromide. What we'll get at first? We'll get CH3 O minus OET. This. Then on the next step, this molecule has been formed. But the most important thing for this kind of reaction, here we have to use a different technique compared to the normal one, that is reverse addition. We have to do reverse addition. Now, what is reverse addition? What we have discussed about the normal addition process, that is excess amount of Grignard reagent has been taken, and to it drop wise the substrate has to be added. But reverse addition just opposite. In reverse addition technique, we have to take the substrate at first, and then we have to add Grignard reagent dropwise. Why is it so? Because earlier we have seen from aldehyde on reaction with Grignard reagent, alcohols will be produced. Now, if Grignard reagent is excess in the reaction container and aldehyde is produced there, they can react with one another to form alcohol. That means our target is to form aldehyde. It is not fulfilled. We will get alcohol molecules. So that's why we have to use here reverse addition technique. And another thing, by this process, we cannot prepare formaldehyde molecule. For formaldehyde, we have to think some other technique. Okay. If we want to do the formation of the aldehyde by not using reverse addition technique, then we can use this kind of molecule. This kind of molecule is orthoester. This molecule name is ethyl orthoformate. This ethyl orthoformate on reaction with Grignard reagent, at first we will get this kind of acetal, then on hydrolysis we will get aldehyde. Okay. So by this way we can prepare aldehyde molecules. Now let's see about ketone. For ketone, the technique is same. Only instead of formic acid ester, we have to take some other acid ester. Suppose we have taken ethyl acetate. So on reaction with ethyl acetate with CH3MgBr and reverse addition technique, we will get stone. And if we want to avoid the reverse addition, we will use the orthoester. Here it will be ethyl orthoacetate. So by this way we can prepare the carbonyl compounds. Now let's see how to prepare carboxylic acids. For carboxylic acid, we can use Grignard reagent with dry ice. Dry ice is basically dry carbon dioxide, and pressure is required. So here we will get first OMGPR, then on its hydrolysis, get carboxylic acid. Here we have formed acetic acid. So by this way we can prepare anything. Dry ice is nothing but the carbon dioxide. Mind it. Okay. Now next, what we have to see, that is some special reactions of Grignard reagent. What are special reaction? Special reaction means, first one, reaction with alpha beta unsaturated carbonyl molecule. This is alpha beta unsaturated carbon. This molecule on reaction with RMGX, two kind of adapt can be formed. Number one is 1,2 addition. What is that? Let's see. Why this is known as 1,2 addition? Because the functional group have been numbered in this way. This is 1, this is 2, this is 3, this is 4. So here R and MGX have been added at the 1 and 2 position. That's why it is 1,2 addition. Another procedure, another kind of addition, that is 1,4 addition. What will be the product there? There it will be this one. On hydrolysis of these two molecules, what we will get? It's on hydrolysis we will get heat on hydrolysis we will get Now, which will be the major and which will be the minor? It completely depends on the size of the R1, R2, R3, and R4, and as well as R. If R and R4 both are quite large, then 1,4 addition will be preferred. If R1 and R2 all are large, R1 and R2, these three are large enough, then 1,2 addition will be preferred. Okay. Next reaction with isopropyl magnesium bromide and diisopropyl ketone. In this reaction, after hydrolysis, will get this one. Its mechanism has been discussed in the class. Another important reaction, two equivalent of aldehyde along with one equivalent of Grignard. Here we will get so these are the some abnormal reaction of the Grignard reagents. 2 and 3 mechanisms, reactions mechanism has been discussed in the class. Okay, and also mentioned in the note. Go through it. Now, with this particular molecule, suppose it is named as P. This P on reaction with alkyl lithium or Li, always we will get 1,2 addition product, always. And with Gilman's reagent or R2CuLi, always we will get 1,4 addition product. 1,4 addition product. That is very important. So in RMGX, we may get 1,2 or 1,4, but for alkyl lithium, always we will get 1,2 product, 1,2 addition product, and for dialkyl cupric lithium, always we will get 1,4 addition product. Okay, that is very important. Okay, thank you.